Suppose that you have to use an app on your phone. What are the two worst things it can do to you? Take up all your storage and be very slow. To create an efficient app, you will need a good understanding of data structures and algorithms. You can think of data structures as just containers to store data. If you use the correct data structures, you can create a really efficient app. But if you use the wrong data structures, you can create an app that is really slow and heavy. Now let's talk about algorithms. Algorithms are just a set of instructions that you need to follow to solve a problem. Algorithms have a direct impact on how fast or slow your app will run or how much memory it's gonna consume. Now that the introduction is over, let's dive straight into the code. This is an array here. Suppose that we have to iterate over the first item. This is gonna take us one iteration. Now, if we want to iterate to the fourth item, it's gonna take us 4 iterations. And in the same way, it's gonna take us 8 iterations to iterate to the 8th item. Now, look at this. Suppose that each iteration takes 1 second. Even though it's really slow for a new age computer, just imagine it for a second. This is our best case scenario because it takes just 1 second. And this is our worst case scenario because this takes 8 seconds. Now, suppose that this was a really long array with n number of items. So if we want to iterate to the last item of that array, it would take us n iterations and it would take us n seconds to do so. This is what we called O of n, and this is big O. Big O is a measure of how your algorithm grows as your input grows. This can be measured in 2 fields. Like for example, in this situation, we are measuring how the time grows as our input grows. So this is called time complexity. And similarly, if we measure how our storage requirement grows according to input, we would call it space complexity. In this case, with respect to time, our algorithm grows linearly. So if we had 1000 items, it would take us 1000 seconds to iterate over them. So this was O of n, linear time complexity. And now let us have 2 arrays and iterate over them at the same time. You can say that this is O of n plus n, that is 2n. But while calculating big O, we drop constants. So we can simplify this down to O of n. Okay, now we are gonna do something interesting. Let's iterate over this array up to n, and on each iteration, we will iterate this array n times. Let's take n is equals to 4. For 1, 1, 2, 3, 4. For 2, 1, 2, 3, 4. This took us 16 iterations, which is 4 times 4, or we can say n times n. That is n square. So this is called O of n square. Take a look at its graph. Now imagine that if n was equal to 1000, it would take us a million iterations to do this. So basically this is a very slow algorithm and you should try to avoid it as much as possible. Now let us try to access the item at the index number 2. It would take us just 1 second. And if we want to access the item at index number 7, it would also take us just 1 second. So this is called O of 1 operation and it simply does not grow. And if you remember, this is the best case scenario that you can have for your algorithm. If the code you have written works at O of 1, you can congratulate yourself. Now let us try to find the item 6 in this array, and we don't have the access to its index. This would take us 6 iterations to find 6, which, as you remember, is an O of n operation. But now let us try to improve our algorithm. We will split this array in half, and 6 is gonna be on the right side of this array. Now we will again split this array in half, and this time 6 is in the left side of this array. And now for the last time, we will again split this in half, and 6 is on the right side of the array. We finally got it. It took us just 3 iterations to find this element. This is called big O of log n, and this is what its graph looks like. And for all of you mathematical nerds out there, this is log to the base of 2. So if you had an array with 1,048,576 items, it would take you just 20 iterations to find your item. To my eyes, that's blazing fast.